Hello guys, it is second part of the tutorial of how to create water jet pump. In this tutorial we will create Stator vanes. We will be using part design workbench, and let's create model in part design. So now here we have the origin coordinate system, and we XY plane create the new plane. And we can change the position of our plan, how you can see in the screen, and on this plan we will create sketch. In the sketch we can create circle. Circle has the diameter of hub like impeller. So for the sketch we will make extrusion, and we set the value. It's random value. I don't calculate the Stator vanes. So now we have to create the airfoil of Stator vanes. And we'll create the sketch where we will create the airfoil parts. It is two horizontal lines. And two vertical lines. Okay, I will constraint, we'll set vertical lines. Okay, and here we will set the angle of our airfoil. It is 45 degrees or 50. Okay. We will set the dimensions for our airfoil. Okay. And axis length we will set 4 points. Of course, it is vertical line, vertical dimension. Yes. How you can see, we can change on the horizontal position, and we'll set the average line of our airfoil. We have to set tangent condition. This is inlet and outlet part of airfoil. Set it in mid-plane, something like that, and let's close the sketch. You can see now let's set circle, and we have to set the points for another sketch. Okay, let's do this because we have to make thickness for our airfoil, and we have to set constraint. It is normal line to our average line of our airfoil. Okay, and for second line it is section and pressure side of our airfoil. Its points. Yes, we can change the position, and we'll set the maximum thickness of airfoil in our circle. Okay, looks good. So let's close the sketch and create another sketch, because we cannot to create the blade if we have some different point lines on sketch. So for that, in XZ plane we will create another sketch. Okay, so we import to our new sketch the points which we can use in new sketch, like part, yes. And for these points we can create the thickness of airfoil with part of circle. This is icon, yes, this, using 3 points. Now we can create leading edge and set the dimension. It will be 2 millimeters radius, and for trailing edge of our blade, some smaller at 1.5 millimeters radius. Yes. Now we are using icon with part of circle and set this pressure side of our airfoil based on our points. Yes. For this it is section side. No, it's false. Yes, and we have changed it. Yes, repeat. And so now we have point this constraint with our circle of leading edge, and the step is make the tangent condition constraint for pressure side, suction side, and our circles of airfoil. Yes, it is tangent. It also tangent condition. So let's split, delete the lines, some lines for leading and trailing edge. Now we have our profile airfoil. For this we have to make extrusion. It is bad icon. Let's set some number. It is random number. It have to be some bigger than diameter of impeller. So how you can see, we created the blade, and now we will create the 8 number of blades. Yeah, this is Stator vanes of our water jet pump. Yeah. We have to set refine. It delete some lines and create one solid. It is more correct in this. Yeah, looks good. Okay. Another part, it is creation of external part of water jet pump. It is pipe with some thickness, and for this we have to create flange also. So let's set dimensions for this. It is horizontal dimensions, it is radius of our impeller, and we have to set some thickness of pipe. Okay. How can you see we cannot set 4 lines the horizontal dimension, and we have to use for it only points. Okay, let's create flange. For inlet and outlet part. How you can see this point and not connected with another, we can use considered constraint for these points. Yes. So now it's working good. Let's delete some lines. Okay, this is good. Delete these lines. Okay, now we have to set dimension of our flange, inlet and outlet. We can make it equal for both. Let's set thickness of pipe. It will be 5 millimeters. And it is length of our flange. Let's set some dimension, and thickness of our flange is 10 millimeters. Yes. We can set condition equal for lines which we want. It is no, it is parallel. We have to use equal. Yeah, it is this icon, equality constraint between 2 lines. Yes. So we cannot to set. Oh yeah, it looks good. And now we close the sketcher, and we have to make a revolve operation for our sketch. It is big dimension, we can make smaller. I think 20 is good. Yeah. Okay, let's create a revolve operation for this. Yeah. How can you see it is pipe with flanges both, and is defect because we have length of our starter blade very big. We can change it. Okay, revolution refined. How you can see the lines is hide this, and now we have to change the length of blade, starter blade. Make it some smaller. Some defect. Yeah, 1 millimeter smaller, and if we repeat so how you can see this defect is hide, and we have a good shape and solid part of our solid vein starter. Yes. Let's create the sketch on face our hub for hole for shaft, because in starter vanes we have bearing. For shaft we have to make it some bigger than diameter of impeller shaft. Yes. Let's create the circle and set the dimension of circle. It can be some random value, 44. Okay, it's good. So now let's make the hole for bearing. It is pocket icon, yes. And for this surface we will make another hole which can be smaller than previous hole. Let's set some number, and we have oh yes, here we set the bearing. And now for flange we have to create the holes. Let's create the sketch on surface and circle, and we have to make constraint. Yes, it's constraint, and set the radius of this hole of our flange. Yes, which it is 6 millimeters radius. So close sketcher, and let's create the hole for our flange. Yeah, it is 10 millimeters. Okay, maybe some bigger. Okay, and now we have created the array, polar array for our hole. For this we will be using z-axis, it is rotation axis, and set 8 holes for our flange. And we will repeat this operation for another surface of our flange. Yeah, okay. So thanks for watching, subscribe and like. Okay.